Okay, now if you look at this question, we have exponential function, we have factorial, and we have polynomial. So if we go back to our strategy, we said if whenever we see factorial, which is kind of the dominant one, we will use the ratio test. So let's try following that strategy and hopefully it will work out. So for the ratio test, we need to find the limit n goes to infinity of an, and in the top we have to write everything the same except for n, we write it n plus 1. An is 3n n squared over n factorial. An plus 1, 3n plus 1, n plus 1 squared over n plus 1 factorial. That's how we do an plus 1 over an. Now we have stack of 4. So we go first with the last, second with the third. And that's what we'll do next. So if we do the first with the last, it will be 3n plus 1, n plus 1 squared. And then we have n plus 1 factorial. And here I think we have n factorial 3n n squared. Little bit of cancellation. We can see that 3n plus 1 over 3n, we get only 3. n plus 1 square over n square, I think we see this before. In the previous example, L'Hopital rule, this would be equal to 1. Doesn't matter. Keep it for now. N factorial is n factorial. We cannot do much. But n plus 1, I can expand it into n plus 1 over n factorial, which is, I can cancel it with n factorial, and finally I will get this one. Limit n squared, and then here I have 3 n plus 1 squared n plus 1. If you find this limit using L'Hopital rule, which is very easy to be done, the answer will be 0. Okay, and if the answer is 0, we know that 0 is less than 1, so the series converges by the ratio test. You need to remember to write the reason. You cannot just say converges or diverges. You need to write the name of the test, ratio test, and you need to explain the reason. How did you apply the ratio test? You apply it by finding the limit of an over an plus 1 over an, and you get into the answer 0, and then you compare 0 with the number 1. So you have to explain all those steps. Going to the next one. I'm very sorry I didn't explain this one when we talk about the strategy, so just let me go back here and write trigonometric part of the comparison test. So trigonometric. We have sine 2n, so the best one we will use the comparison test, which is sine 2n 1 plus 2n, and then we need to compare it with something. Usually sine is less than 1, and if you compare this one, we compare it with dominant, and I'm sure this is correct in that way. Maybe we just have to check if this is correct or not. Yeah, I think it's correct. Okay. Now what we know, this is converges because it's geometric series with common ratio, which is r equal 1 over 2 less than 1. So by the comparison test. The series converges. Okay. Okay. The next one, I think it's better here. I think this reminds you of something very, very much similar to the factorial. It's not quite factorial, but similar to the factorial. So why we don't use the ratio test here in this question? I really prefer to use the ratio test. Okay. So I need to find L, which is limit n goes to infinity, an, and at the top you need to write everything similar to the one that is down, but you just change n into n plus 1. So let's please focus with me on this one. What is an? It is 1 times 3 times 5 times 2n minus 1 over 2 times 5 times 8 times 3n minus 1. Now in the top, I will do the same thing, times. And instead of n, I will write n plus 1. So it will be 2n plus 1 minus 1 over 2 times 5 times 8, 3n plus 1 minus 1. Now we just need to find the term before that one. It will help me so much if I know what is the previous one. Now how do we find the previous one? Now if this is n plus 1, the previous one will be just n. And I think you can see now the cancellation are for free. Because all what I did is just I add an extra terms. That's all what we did. The cancellation is this one as a whole with this one with this one, and finally we got into n plus 2 minus 1, 3n plus 3 minus 1, which is limit as n goes to infinity of 2n plus 1 over 3n plus 2, and the final answer is 2 over 3 less than 1. So by the ratio test, the series converges. Okay. If you want to take a snap picture of this. The next one, I will not solve it because it is very easy, and the hint is use the test for divergence. Why do you need to use the test of divergence? Because if you try to use the comparison test, it will not really work out that much. Okay, so please use the test for divergence. Now the last question is this one, and we will solve it in the next final video of this section.